Okay, so you should be coming back from the video from Whiteboard Maths, which shows you where this formula comes from or how you can kind of derive this formula. This is the formula, either one of these will work. This is the formula for the sum in a finite geometric series, right? So if you want to add all the numbers up, but you don't want to do it by hand because that can take forever, this is kind of a shortcut to get you there. You can use either one of these. Now in the video, he calls the first term A instead of A1, but whatever, we can kind of translate. So we have A1 instead of A. That's kind of what you got there. So let's use that formula, and let's actually just go back and look at some of the problems that we looked at before and do it a different way so you can see how this formula works and that it actually works. Okay, the first one we did, whoops, not that one. First one we did was 17 from this section. Now we did this out by hand. We actually just listed them all out, figured out the pattern, finished finished the series, and then added them all up. Let's use the formula. Okay, so the formula is the sum for n terms. Now we want 9. There's 9 terms in this. So the sum for these 9 terms is equal to, on top we have 1, and that's just a regular 1. We just leave it there. So it's always going to be a 1 there. 1 minus r to the n. Okay, so r is going to be our, oh, sorry, we forgot. We want the first term as well. So, sorry, go back one step. Let me write the formula up here. So we have get it together. Okay, so we have a1 times 1 minus r to the n over 1 minus r. All right, sorry, that's our formula. So in this case, specifically, we want sum of 9 terms, and we need to start with the first term, which is 2. Right, 2. And then 1 minus r to the n. Okay, so this is 1 minus, and then r here, what's the common ratio? We're multiplying by 2. So the first term's 2, r is also 2. That's not always the case, it just happens to be in this one. And then we want it to the n power. And since there's 9 terms here, this is going to be 2 to the 9th. And I'm going to divide that by 1 minus r. So all I'm doing is just filling this stuff in. A1 is easy to get, it's the first term. R is the common ratio, we're multiplying by 2 every time, so that goes here. N is the number of terms, that's 9. R is the common ratio again. Okay, so, and this is a 9. So the sum of these 9 terms is equal to 2 times, let's see what 1 minus 2 to the 9th is. I'm just going to use my calculator for that. So this is negative 511 over negative 1. Okay, so 1 minus 2 is negative 1. So these are going to cancel, and I'm basically going to have 2 times 511, which is going to give me 1022. Cha-ching! Right, which matches our previous answer. Sorry, the glare from that light is kind of messing that up. So that's how the sum formula works. Okay. Now sometimes you can get some pretty big numbers here, so that's okay. This is a kind of like an exponential growth, so it's gonna get big quick. Let's take a look at number 19 and let's do it with our formula. Okay, our formula doesn't really need you don't have to go through all of this work if you're going to use a quick formula. You can do it this way, and we didn't even finish this because we didn't add all these numbers up, but we'll use that to double check. So let's go through and see what we need for our formula. Our formula is, so I always write A. This should be S though, we're talking about a sum. The sum of these 8 terms, right? So we're stopping at 8, because there's 8 terms in the sequence, that's what the sigma notation tells us. And that's going to be equal to the first term. So we would have to go through and find the first term. So if I plug 1 into this, I get 5 to the 1 minus 1, which is 5 to the 0, which is 1. So the first term is 1. And then I times 1 minus, so then we have r to the n. Okay, so we got to kind of figure out what r is. There's a couple ways to do that, but if you look at your function or your explicit formula here, this is your r, right? When you look at an explicit, it's like a1 times r to the n minus 1. So if you can find the base of the exponential expression, you're going to find your r. So here r is 3, here r is negative 2, here r is 3. If you can't get that or you're not sure, you can list out a few terms and figure out, oh, this is multiplying by 5 every time. But again, the base of your exponential function is going to tell you that. So since this is an exponential expression and 5 is the base, I know r is 5. So I want r to the n. So that'd be 5 to the 8th, right? Because we're going out 8 terms in this guy. Okay, over 1 minus r. So that's a lot easier to do than doing this all the way out and then adding them. Let's just kind of see what that's going to give us. So let's do 5 to the 8th. That's going to be a pretty big number. Okay, so that's that guy right there. Let's do 1 minus that. Okay, and then we're going to divide that by 1 minus 5, which would be negative 4. So we have negative 390,624 over negative 4. Negative 9, 7, 6, 5, 6. Okay. Now that looks a little too big. The problem is, and what I just noticed here, is that I went out too many terms, right? This is only supposed to have 8 terms. So we should have actually stopped this right here before, because we didn't need to go out that many. So this should be our sum right here. Okay. And if you're kind of wondering, like, well, how is that going to match? That's the problem. This one is supposed to have 8 terms, and I went out 9 because I was thinking about this one. So let's add up all these up. So this is your answer, but just to double check, and you probably wouldn't do this every single time, but let's just check. We're going to add all these numbers up. So 1 plus 5 plus 25 plus 125 plus 625 plus 3125 plus 15,625 plus 78,125 equals, awesome, 97,656. That's exactly what we wanted. Okay, so just kind of showing you that that sum formula actually works. You can, write out the whole series using your sigma notation to get every single term, and then add them all together. Or you can use the sum formula that we came up with and come up with it that way. So that's kind of what I would recommend. So that's how you do these guys. Let's take a look at one that has some negative numbers in it, just to kind of help you out here. So we need a couple things here. Let's start with our formula. It's this guy right here, right? The sum is the first term times 1 minus r to the n over 1 minus r. So the first term is negative 3. Okay, r, notice it's like negatives, negative, negative. Now, it doesn't have plus in between, because if you have negative 3, negative 6, negative 12 in a sequence, when as soon as you add the addition signs, you have negative 3 plus negative 6 plus negative 12. And so instead of writing plus negative, plus negative, plus negative, they just put a minus. But this is still a series. You're just basically adding a negative number. So this is a series, even though you don't see the additions. It's like plus minus 6, plus minus 12, plus minus 24. But what we're doing is we're multiplying by positive 2, because those terms are staying negative every time. Okay, so first term, negative 3, times 1 minus r to the n, so 1 minus 2 to the 9th. Okay, be careful with your order of operations. Probably should write it like this, because only the 2 is being taken to the 9, not the negative. So do the 2 to the 9 first, and then do 1 minus. That's probably the only, issue you really have to worry about, is the order of operations, so be careful. So we got negative 3 times 1 minus 2 to the 9th. Let's do this, the 1 minus 2 to the 9th part. Okay, negative 511 again. So negative 3 times negative 511 over negative 1. So basically negative 3 times negative 511. Sorry, positive 500, because the negatives are going to cancel. So this should come out as negative 1533. Because this negative will cancel with that negative. You'll still have the negative from the 3, though. Okay, cool. So that's how you do that. The last video that's gonna be coming up in a minute is infinite geometric series. So one thing that I wanted to just make mention of really quick is you'll see this dot, right? That's called an ellipsis, which means and so on, and the pattern continues, right? Et cetera, et cetera. So if you didn't have this right here, you would almost think like that looks like an infinite series because it just keeps going, right? They don't give you the last term to say it stops, but they do say, oh, by the way, n is equal to 9, so there's only 9 terms. So it's so on and so on and so on until the 9th term, right? And that's kind of where you stop. So these guys here are all finite, right? They're a series that ends. They only have a certain number of terms. So you can see, n equals 9, n equals 6, n equals 8. And then here, of course, on top with our sigma notation, we got the number of terms in the sequence, or the term number to stop on. Over here, we'll get into this a little bit in the next video, is an infinite geometric sequence, or series, excuse me. So you have the dot, but you don't have like a final term, and it doesn't tell you how many terms are in the sequence, so you're just going to assume that there's infinitely many. And this is what we're going to go over next.